Dear students, we have already started a new topic, that is circular motion, and there was a introduction class. I have discussed some introductory things about circular motion, and today I will go to directly the important parts of this chapter, that is the angular variables, that is angular displacement, angular velocity, angular acceleration, etc. So I like to discuss today about some angular variables. Okay, so today's class is completely dedicated to some angular variables, and these kinds of dynamical variables we have discussed earlier in the chapter kinematics, that is for study of actually translatory motion. But here we will discuss about circular motion, and the motion of the object will be constant to move along the circle, okay, along the circumference of the circle. So the only thing that we need actually again and again, that is angular displacement. So first we have to know, and you might have studied in your earlier class, that what is the measurement of angle, how we can measure angle. Okay, so let me first give you the concept of measurement of angle. Okay, so this is a very important topics when you want to study about the circular motion. Okay, so this is the measurement of angle. And how you can measure angle. So if we have an arc like this, and suppose this is a center of this arc, this is a part of circle obviously, and let me take this angle as theta, and the radius of this arc is r, and if its length is L, then obviously I think you know that theta will be equal to L upon r, or you can say L is equal to r theta. Okay, so this is the initial requirement if you talk about angle, and this angle is actually measured in unit of radian. Okay, so you need to know about the relation between the radian and the degree. So this 360 degree actually means 2 pi radian. Okay, so you can write it like this, or you can write it like this, that 2 pi radian means 360 degree. So you can convert from degree to radian or radian to degree by using this relation. So if you take 1 degree, then it will obviously be 2 pi radian upon 360 degree. So that will be obviously pi radian by 180. Okay, so this is not degree actually, 180 only. Okay, similarly if you talk about 1 radian, then it will be what, 360 degree upon 2 pi, so it will be now 180 degree by pi. So this will be 1 radian is equal to, and this will be 1 degree is equal to, so degree radian can be converted like this. Okay, now we can start our topic, that is angular displacement. So when we talk about angular displacement, obviously we have to draw a circle. Okay, so let us take, this is the circle actually, or you can say the trajectory of the particle. So let me suppose that the particle is initially at this position, this is P, and after some later time it will go this position, and the angle made by this OP, initially let me take this angle is 0 degree, and then after some time it will go some distance and it will make an angle theta. Okay, and this theta is actually called angular displacement, that is the angle actually, this angle POQ, you can say this angle POQ is actually called angular displacement. This is angular displacement. Okay, now the big question is that, is theta is scalar or theta is vector? This is a very interesting and difficult question, you can say, for the student, that is this theta is vector quantity, this angular displacement theta is vector quantity, or this is a scalar quantity. This is a very interesting question, and there are huge confusion among the students. So let me clear your confusion, that this theta can be treated as, actually these are pseudo vector, you can say, I will tell later on, But initially you can say, simply you can say, just this theta can be treated as a vector quantity only if this is a small theta. This angle is very small angle. Okay. So if this theta is large, if this theta is large, then you can say this is just scalar. This is just scalar. But if theta is very small, that is, instead of theta, if we use d theta, so that means theta is very small, and in that case you can say this theta is vector quantity. This theta is vector quantity. Why? Because the basic rules of vector algebra, that is the addition, the property of vector addition, is not followed by this theta, but is exactly followed by this d theta. If you talk about this thing, that is very simple, that if you talk about the commutative property of vector algebra, you can understand by using this simple vector algebraic rule, that is the commutative property. So if you talk about commutative property of vector algebra, commutative property, if you talk about commutative property of vector algebra, then if you have two vector a and b, then if a plus b is equal to b plus a, then you can say these two vectors are commuting in nature, at least for their addition operation. Okay, but if you talk about theta, that is capital theta, and if you take theta 1 and then theta 2, if you rotate some object at some particular axis with respect to some particular axis, first you can rotate a book also, you can and take the experiment, you can do the experiment very simply. If you take a book, okay, and first you have to rotate 90 degree about some axis, then you have to again rotate 90 degree about some axis. Now if you back once 90 degree, then again 90 degree anti-clockwise rotation, first if you do clockwise sense, then you again, if you again rotate anti-clockwise sense, you cannot reach to the same face of this book. So if you rotate some angle, some large angle theta 1, then again some large angle theta 2, then if you reverse the process, if you now rotate theta 2 by angle theta 2, and then if you again rotate some angle theta 1, then you can see these two are not equal, because you cannot get the same face of the book. You can do the experiment very easily. So in that case, this theta 1 not plus theta 2 not equal to theta 2 plus theta 1. But if we take a very small angle, that is d theta, then you will obviously get that d theta 1 plus d theta 2 will be must be equal to d theta 2 plus d theta 1. So you can simply say that this d theta is nothing but vector quantity, but this large angle theta is scalar, just scalar quantity. Okay, and what will be the direction of this d theta? If you talk about d theta is vector quantity, so you can just treat this thing as axial vector. This d theta, this vector quantity, you can just take this d theta as axial vector, nothing but this is an axial vector. And being an axial vector, obviously its direction should be along the axis. So if you take this circle like this on this plane, obviously if we take this circle on this plane, then obviously the axis will be like this. So if we rotate, if the particle is rotating along this anti-clockwise rotation, so if you curl your finger like this, then your thumb will be directed along the theta. Okay, if you curl your finger along the rotation, then your thumb will give you the direction of theta. So obviously if it is in anti-clockwise direction, then theta will be in this direction, and that is obviously d theta, because you cannot theta is scalar, but we can d theta is scalar, and this kinds of quantity is called actually pseudo vector. So this d theta can be treated as pseudo vector, and please remember, all the axial vectors are actually that I am going to discuss about this angular displacement, angular velocity, angular acceleration. All are actually pseudo vector. All angular vector, you can say angular, or you can say these are pseudo vector. These are pseudo vector. Okay, so please remember this thing. Okay, now here you can see, if this theta is very small, that is d theta, if we take this theta as now d theta, okay, then obviously you can say that this is now, if this is theta, then this is just close to straight line. This PQ is close to straight line. If this is d theta, then this PQ is close to straight line. So it will give you now the linear displacement. Okay, so it is now motion like one dimensional motion. If it is straight line motion, then if you take this as the S, or you can say this is a ds, so it will be better to say ds because this is very small. So if this is ds and this is d theta and this is r, so obviously you can write the relation between this ds and d theta and r also. You can involve r, ds and d theta, and in that case you will get a relation between angular acceleration and the linear acceleration, you can say. So in that case, again, if you talk about d theta, then according to the definition of angle, obviously d theta will be ds upon r. So ds will be r d theta. So ds will be obviously r d theta. So you can say very easily that the linear displacement, if this is taken as linear displacement, obviously this will be linear displacement only if you take this d theta is very small. If d theta is large, then we cannot say that this is linear displacement. You can say in that case this is a distance travel but not displacement. But if you take this d theta is very small, then this d theta will be itself a vector quantity, and obviously at the same time this linear displacement will obviously be a scalar quantity in a vector quantity. So all the vector quantities are involved now. Okay, so our equation will be very beautiful. You can guess that which kinds of product it should follow, because all the three are vector quantity. Can you see here? All these three ds, r and d theta are vector quantity. Can be treated at least as a vector quantity. Can be treated, because this is nothing but a position vector with respect to O. This is nothing but a position vector. R is a position vector. So this is obviously a vector quantity, and this is I have said that this is actually pseudo vector. So you can treat this as also vector quantity, and now this is also a vector quantity. So obviously they will follow cross product, because if these two are vector quantity and this is also a vector quantity, so it should follow cross product. Okay, why? Because you know from the rule of cross product, I think you know that there are two kinds of product of vectors. Actually there are two kinds of product of vectors. One is scalar product and another is vector product. And when three vectors are involved, then if you talk about a, b, c, then c vector will, if c is equal to a dot b, then obviously c is scalar quantity. But if we write c is equal to a cross b, then obviously c is vector quantity. So if c is equal to a cross b, then c is vector quantity. So obviously if there is a relation like this, c is equal to ab, so you can guess from here which relation should follow among these quantities. So if this is vector, this is vector, this is vector, then obviously it have to follow this relation. So you can see easily from here that the vector relation between them, what will be the vector relation between them. So this is just a magnitude, that linear displacement, at least when the particle is rotating along circle, that linear displacement will obviously be equal to, you can say radius of circle into angle, or angular displacement, you can say angular displacement. sometimes people write that S is equal to r theta. You can write if you want, but I think this is actually not the correct notation, at least, because this is, if you say that this theta is large, then obviously this is not the displacement. In that case, this is the distance travel. This can be only displacement if instead of S, if you write ds, then at least your notation is very good, that which is directly suggest that ds is small and d theta is small. But this kinds of notation is not very good actually. Okay, so I am advising you always to use this kinds of notation, at least for this actually for linear displacement. Okay, if you want to take this ds as a linear displacement or pq as linear displacement, then it is better to say this is ds. And obviously this have to represent as a d theta, because large theta is not in that sense a vector quantity. Okay, so please keep in mind. Now let me understand that what will be the vector relation between this, okay, between ds, r and d theta. This is the scalar relation actually. This is actually nothing but the relation between angular displacement and the linear displacement. This is known as. Now what will be the vector relation? This is very important, because from this vector relation, we can easily find out the other relation when we talk about angular velocity, when we talk about angular acceleration. That will be direct consequence of this thing. So this is a background. Always the first thing, that is displacement or the position displacement. These two things are very crucial, because for your further study of these topics, you need to use these things again and again. So please understand these things, okay, with detail, and something you have to know about this thing. So what will be the relation between the ds, r and d theta? So obviously two possible cases are there, because you know always if c is equal to ab, this is very interesting. If c is equal to ab, always two cases are possible. At least if these three are vector quantity, then obviously c can be written as a cross b, or c can be written as b cross a. These two possibilities are there. But which will be correct for this thing? Here the relation is ds is equal to r d theta. So you can write, if you want, that ds is equal to r cross d theta. And obviously if you want, you can also write that ds is equal to d theta cross r. At least initially this relation suggests these two kinds of relation. Now which one will be correct? Not correct. Which one we have to take? This is obviously according to the sign of the rotation, in which direction the particle is rotating. If this is in anti-clockwise direction that I have taken here, so in that sense you have to use that which relation give you this anti-clockwise rotation. Okay, so you can just verify this thing. You have to always verify. So if you take that this is my x-axis, so let me take this is my x-axis. If you take this is x-axis, and along this direction, that is along the tangent, you can take this as a y-axis. So your direction of ds is along y and direction of r is along x. Okay, so and obviously this d theta is perpendicular to this. So these three vector, one is d theta, another is r, and another is ds, are perpendicular to each other. So you can take these three vectors along x, y and z axis easily. You can take this as along x, y and z axis. So please see, always you have to understand the thing by using the unit vector. This is x and this is y. So obviously along r, this is I cap. So r can be written as r I cap, obviously, and ds can be written as ds j cap. Now here is d theta. So d theta will obviously either along k cap or along minus k cap. You have two opportunity. But you can see here, always you can see, I have told you that if you curl your right hand finger, then this thumb will give you the direction of d theta. So d theta will be obviously along k cap direction. So obviously d theta will be along k cap direction outward from this board. So you have to write this d theta as d theta k cap. Now you have to check just which relation give this three, which relation suggests this three direction I cap, j cap and k cap. So please put here r cross d theta, put r cross d theta. So r is I cap, you know, and d theta is k cap. So what is I cross k? So please remind your class, first class of vector dot product class, okay, dot and cross product class. So there are three, like one is x axis, another is y axis, and another is z axis, and this is I cap, this is j cap, this is k cap. Now what is here? I cross k. So if you take I cross j, then k cross I, then j. But if you rotate anti-clockwise, then you will get negative always. So if you take I cross k in this direction, then it will be obviously minus j. So this relation gives you ds along minus j cap direction, but ds is actually plus j cap direction. So let me check this. Here actually d theta cross r, so this is k cross I. K cross I. So k cross I will be j, and this will give you the correct result. So obviously you have to take the vector relation as this, ds is equal to d theta cross r. So finally our vector relation will be, obviously this is the scalar relation, the ds is equal to r d theta, and your vector relation will be ds is equal to d theta cross r. So please remember these two relations. One is scalar relation, and another is vector relation. So please keep in mind these two relations, because you will use again and again these two relations for the further topics when we talk about angular velocity, angular acceleration.